Okay, we're going to talk about a motor. It's a standard induction motor. Okay, it's a 9-lead motor. There'll be a diagram on blackboard I want you to look at. It'll be a 9-lead motor. It may have 12 numbers on it, but 10 and 11 and 12 are hooked together on the inside. I'll have them both. They're the same motor, but normally right here at the junction box, there's only 9 leads brought out, 1 through 9. T1, T2, T3, T on through 9, okay? Now, we're going to talk about checking a motor. The first check you do is going to be on the ohm scale, and we're going to check the windings. We're going to check for equal. On a 3-phase induction motor, it's so stinking easy. Everybody goes, oh, 3-phase, it's so hard, it's so hard, it's so hard. No, it's not. No, it's not. Okay, this is hooked up for 480. Okay, all your induction motors, dual voltage motors, 240 and 480, hook up the same way. For 480, 1, 2, and 3 hook to your 3-phase, and then 4, 7 wire nut together, 5, 8 wire nuts together, 6, 9 wire nuts together. If you can spend a little time memorize that, that's great. Now, if you're hooking it up for low voltage, 1, 7 hooks to the first power lead, 2, 8 hooks to the second power lead, 3, 9 hooks to the third power lead, then 4, 5, and 6 all wire nut together. And that's for 208 or 240 for a dual voltage motor. But we've got this hooked to 480. Now, what we're going to do is use an ohm meter. We're going to get on T1, okay, and T2. T1 and T2. I see 13.5 ohms. So, that in itself doesn't mean anything. But we've got 3 tests to do here. T1 to T2, T1 to T3, and T2 to T3. Those are the 3 tests you got for a motor. So 13.5 ohms. What we're going to look for is if we're within 10% of each other on those 3 readings. Okay, so 13.5, T1 to T3, 13.6. Okay, a 1/10 of an ohm difference on 13 ohms. That's well within 5%. We want it within 5, but absolutely within 10. And then we're going to do T2 to T3, 13.4. So we're only a 1/10 of an ohm off. So, ohming out the windings, this motor's good. Within 5%, but absolutely within 10%, 13.5 ohms. Now, the bigger the motor goes, the bigger the winding wire and the lower your reading will be. If you get on a 25 or a 30 horse motor, you may only read 1 or 2 ohms. So it gets harder to read like that, but I still read it just to make sure, first off, they're not open if I have a problem with it, and second off, best I can on a bigger motor within 5%, definitely within 10. Now, the other test that we make for motor is a megger test. Okay, and this is a megger. And what we're doing here, a megger test is just like if you build a home and you are putting in your plumbing. You're going to pressure test your plumbing pipe. So if you're putting in 250 pound per square inch pipe, your plumber may pressure test it to 200 pounds or 2 1/4, whatever. And he's going to pump that up, he or she's going to pump that up overnight, see if it holds pressure overnight. That's their pressure test for that. Voltage is electrical pressure, just like water pressure. So the higher voltage, the better the insulation has to be. These motors here are 480 volt motors. So we normally measure them on a 500 volt scale, okay? So the proper way to measure is I'm going to find a screw or something that is metal. This housing, all these windings have to be isolated from the housing. This housing is grounded by code. It has to be grounded because the public can touch the housing of a motor. You can touch the housing of your pool pump. So it has to be grounded so that if any of these windings go to the case of the motor, it's going to blow fuses or trip a breaker. So I want to make sure I get a good ground. I'm putting this on a screw there. I'm putting this other one on a different screw, okay? Now on this here, and we'll cover it more whenever we get in class, I've got it set on 500 volts. I'm going to press that test, and I get 0 megohms, okay? 0 megohms. That tells me that both those connections are good. Now, I don't care which one, I'm going to take it loose, not bother the other one because I know I've got a good ground, and hook it to any one of the other 3 leads. Because we are charging every winding because this motor is a star, okay? So it's a Y connection. So by hooking it from ground to any one of these, we're charging the whole, all the motor windings up to 500 volts. Now, this says 550 megohms. At 550 megohms, that's a good reading on this motor. Now, these are a little funky. I don't know why Fluke built them like this, but if I take this loose, we know that's infinity. It still reads 550 megohms. That's infinity on this megger, okay? Now, let's talk about what's a good reading and what's a bad reading. The old reading, if you're asked this in a job interview, you want to write this down, okay? Excuse me. 1 megohm per 1,000 volts of applied voltage plus 1 megohm, okay? This is a 480 volt motor, rounded off to 500, okay? So 500 is half of 1,000. So half a megohm plus 1 megohm, the old answer, the minimum reading this would have to read be 1.5 megohms. The new answer is 1 megohm per 100 volts of applied voltage. So this is a 480 volt motor, rounded off to 500. So at 500, you'd expect 5 megohms to be the minimum reading. We read 550 megohms, which is really infinity. So this motor has really good installation integrity. All right, so that's how we check a motor. Those are the only 4 tests we do. 3 here looking for equal, then with an ohm meter, and then 1 here checking the integrity between any lead and the case. Now let me say this, when you check between any lead and the case, the other 2 leads have to be clear of the motor junction box and ground. One caution there. All right, so watch this, make sure you understand it. Email me any questions, and I'll see you in the lab.